Okay, so your question is to write a function that consumes a string and determines whether or not it is a palindrome. Okay, cool. So just to be clear, a palindrome is a string that is like the same in both directions, right? Yeah, cool. So could it be a sentence or is it only a word? No, it could be a sentence. Okay, so there could be spaces. I'm just gonna take some notes real quick and write this down. So palindrome, there could be spaces, there could be a sentence. Am I thinking about are gonna only expect like alphabetic characters, or could there be other characters? Let's just do alphabetic. Okay, cool. So let's do alphabetic characters. I guess just about the input. It's a string, so could the string be empty or null? It could be both. Okay, so it can be empty. It can be null. The only other question that comes to mind is case. So like in the English language, like MOM, mom. If you have a capital M, it's still a palindrome. But for the sake of the program, should I consider that a palindrome, or should I assume that everything's going to be lowercase? Everything will be lowercase. Okay, so I'll just expect everything to be lowercase. Okay. All right, so that answers most of my questions and kind of some of the constraints to the input. Do you have any other you'd like to add? No? Okay, cool. So before I go too deep, I'm just gonna try and come up with a couple, I guess, like tests or examples to address my constraints to make sure that I'm on the right track. So I guess we could start simple. So like empty string. I'm not sure if an empty string is a palindrome. I think it is because technically it's nothing in one direction and in the other. Is that right? Yeah. Okay. Cool. Thank you. So that is a true instead of just returning boolean. So if I get null, I guess I could just return null, right? Yeah. Okay. Cool. Thank you. So return null. So I'm gonna put a check mark over here on this side, and then maybe later we can come back and test it, and then I'll give it 2 check marks. Okay, so lowercase, so let's just have, A, B, C, that is false. And then we have A, B, B, A. So if I just like cut that in half, that's true. I guess I don't know if this will affect my algorithm, but just thinking about it, like this isn't a palindrome. So is the string even, the length even or odd, or it doesn't matter? It could be both. Okay, it could be even or odd length. Even. I'm just gonna write that down just in case I need to worry about that later. Okay, so palindrome, and we'll just do. I think this is a classic one, race car. That's a good one. Okay. Alphabetic spaces. I didn't cover that one, so let's just do B, B, A. So those are all spaces, and that looks like true. So now we've covered that even and odd things. Covered that. Okay. Covered that. Okay. So I think I've got all of my examples. I don't have any more that I think would be that beneficial. Is there any more that you would like to add? No? Okay. So I'm just trying to come up with like a basic solution, I guess, to start. So I'm going to use Java. And I know in Java there's a string function that returns the reverse of a string. So like the simple solution for this would be just take a duplicate string and set it to the reverse of the string. And then I could just compare whether or not those are equal and then return that. So that's like a simple solution. I know it's not super efficient, but what do you think about that? That's pretty good, but let's see if you can make it better. Okay, well, there's not a lot going on there. So I guess to make it better, I have to address, well, I'm using extra space, right? So I guess I could try and use less space. I would need to use more time, though. So let's see. Well, I guess how did I determine that this was a palindrome? Before I said I cut in half, but I realized that's not really what I did. What I did was I kind of looked at the beginning and the end, and I kind of just worked my way inward, kind of like 2 separate pointers. As with this one, those are good. And then here, I know it's false because I found a mismatch. So I guess what I'm thinking is if I could somehow have 2 pointers, one at the beginning and one at the end, and then kind of work my way in, as long as I don't have a mismatch, I have a palindrome. And if I have a mismatch, then I'll just, stop moving inward. Does that make sense? Yeah. Let's code it. Okay, cool. So I'm going to be writing in Java. Okay, so public. Is palindrome. We'll take string S. Okay, so I just want to get my easy cases out of the way so I don't forget about them. So if S is null, I'll just return false. Okay, now I gotta check that. I'll probably need the length later for iterating, so I'm just gonna get that now. So int n equals s dot length, and now that I have this, I can easily check if s is equal to 0. So now I've already got this case, and now I got this case rather. Now I'm gonna get this case. So if s, which is the length, if n, which is the length, if n is equal to 0, I'll return true. Okay, so now I've got my two edge cases out of the way, and now we can move inward to the function itself. So like I said, I need 2 pointers, and I need to iterate inward. So I'm just going to use a basic for loop. So for and I is equal to 0, I is less than n, which is our string length. We're going to continue. Now, I guess what I said is, as long as I don't have a mismatch, I continue. And if I do, I'm going to break. So I need to get the character at the beginning and the corresponding character on the opposite side of the string. So I guess I can just check it using the character at char at function. So if s dot char at, so this is going to be my left-hand pointer. Char at I, so this is coming from the left, like I said. So that's char, so we can just do equals. So now I need to get the this is a little bit more tricky because I need to get the character at the end that's also moving inward. So I guess I need to go to the end first, so s dot char at, let's see. I know I have to go to the end, but then I have to work inward. I also need -1 for the index. And then I guess, well, if this pointer is going left, then likewise, that's the offset, so it's the same offset. So if I also subtract that offset, then I have the corresponding pointers. And now, I don't want to know whether or not they're equal, because that would be a wasteful check. I want to know if they're not equal, because if they're not equal, then I can stop right here. So that's an early termination. And then in the case where I get out of the for loop, that means I've never had a mismatch. So I have a palindrome. So here I can just return true. So I think this is good. Does this make sense so far? Yeah. So why did you go to n? Well, I went to n because I need to iterate over the string, but I guess I don't need to iterate over the whole string, because if I come here, that means I'm going like this, and that would kind of be counterintuitive, because if I get to the middle on an odd number string, or I cross on an even number string, that is a palindrome. So I guess I don't really need to go to n. I probably only need to go to n over 2, because once I get to the middle, I'm done. Okay, so now I feel a little bit better about this. That was a good question. Thanks for asking. So I can go through this, or I can just move on to test cases, whatever you like. Let's do some tests. Okay, so we'll check these off here. So if empty string, return true. That's covered right here. Okay. Null will return null. That's covered up there on the first line. So A, B, C. So we'll get down to here. The first check will be if A doesn't equal C, which it does not, so we'll return false. A, B, B, A is equal to A, B is equal to B, we'll return true, and so on and so forth. So I think this is good. All of my test cases have passed. And if you have any questions or you want me to go through any more, please let me know. Thank you.